Hello, everyone. My name is Eugene Goldstein, and I have been honored to present 4 lectures on the geometric design of major urban roads as part of your transport systems course. The aim of the lectures is to provide you with the theoretical background to geometric design of major urban roads and provide an overview of a performance-based road geometric design process. As part of the lectures, you will learn about the fundamental design considerations, design inputs that would need to be used to develop the geometric design, the geometric design principles related to horizontal and vertical geometry, road cross-sections elements, and the road safety. The information that I would provide during the lectures should be only used as a guidelines. In practice, the guidelines must be applied sensibly and flexibly in conjunction with your skills and judgment as a potential designer. As a designer, you should have regard for particular circumstances in each case, including the importance of the road under your design, the nature and amount of traffic expected to use it now and in the future, and the cost and implications of the alternatives. Compliance with the guidelines does not relieve you of responsibility for establishing that your design was suitable, appropriate, and adequate for the purpose stated in the client's project requirements. In selecting design criteria, you should take care to ensure that the selection of a minimum criteria does not lead to an unsatisfactory or unsafe design overall. On major urban roads, the expectations of drivers are normally for a high standards facility. You as a designer should remember that consistent selection and application of design standards over a reasonable length of road is desirable, and a consistent and appropriate signing and delineation can compensate to some extent where less than desirable geometric standards are unavoidable. However, the use of signage and the line marking should not be seen as a substitute for safe geometric design. Prior to designing major urban roads, I would be very keen for you to familiarize with a glossary of terms used in the road and traffic engineering practice. For these purposes, the Australian standards AS 1348/2002 is probably the most suitable document. It will provide you with an alphabetical list of terms in road and traffic engineering. For example, road or roadway, a route trafficable by motor vehicles in law, the public right of way between boundaries of adjoining property. Freeway or expressway. In Victoria, we're using the term freeway. In New South Wales and Queensland, they have got tendency to use the term expressways. There's no difference. The fundamentals are the same. A divided highway for a through traffic with a full or partial control of access, and generally with great separations and intersections. In other words, it's a roadway that would allow a free traffic flow. Overpass. Some of you may recognize this overpass, some of you may not. It's actually, picture has been taken about 19 years ago, not about, it's 19 years ago. And it's Collins Street extension. To the right, these days, you may see the Southern Cross Station, and to the left, the H headquarter, and both to the right and left, these days there is a high-rise buildings, and the extension is actually taking closer to the, further down to the waterfront. What is the overpass? It's a grade separation where the subject carriageway passes over an intersecting carriageway or a railway. In this particular instance, if you're familiar with the area, and you can see actually in the photograph, it's actually crossing a range, I can give you the exact number, 11 railway lines. Viaduct. A long bridge composed of a series of spans, usually of land. Bridge rotary interchange. An interchange between a freeway, an expressway, and a surface road or roads in which the ramp terminals connect to a roundabout which is grade separated from the freeway or expressway. Typically, you would see this type of structures on the approaches to the large cities. It is highly unlikely you will see this type of structures within the cities. It requires a lot of land, and land, as you're probably well aware, within the cities are quite expensive. Elevated roundabouts, it's a quite interesting structure, quite rarely where it can be used, but obviously based on the client's requirements, there is a room to imagination, and structural engineers exercise their intelligence to come up with a very impressive structure. Charles Grimes Bridge, that structure has been built, designed and built not far away from the Collins Street, crossing Yarra River. For those who know the area, the picture has been taken about 20 years ago. Okay, there is a new complex of a DFO Southern Wharf Shopping Centre. Now, the purpose of this picture is actually to demonstrate to you, by gaining knowledge, by learning about the fundamentals of the geometric design of major roads, by familiarizing yourself with standards and the guidelines, you can design this type of this sort of wonderful structures. One of the main sources of the knowledge, okay, other than my lectures, okay, and my notes, you can use the available standards and the guidelines. The most suitable standard, or the guideline rather than the standard, is the Guide to Road Design, part number 3, Geometric Design, prepared by Austroads. Okay, this document provides road designers and other practitioners with information about the geometric design of road alignments. At the same time, this document is not just about the road alignments, it's also about the design parameters, about the speed parameters, about the horizontal and vertical geometry. So the design parameters that outline in the guidelines are related to road classification, design speeds, design vehicles, alignment controls, cross-sections components, including traffic lanes, shoulders and verges, and provision for public transport and cyclists. The design parameters include operating speed, desired speed, posted speed, design speed, and their relationship with each other. Horizontal and vertical alignments include development and application of circular curves, superelevation grades, vertical curves, procedures for grading of road alignment, and determination of side distances across vertical curves. You will learn, and I will present during my lectures and outline the various elements that you would need to know and learn about to be able to develop geometric design of major urban roads. The art of the geometric road design, what is it? It is a three-dimensional combination of the elements that establish the road layout, horizontal and vertical geometry, pavement and median widths, crossfalls and superelevations, pavement types, and intersection forms. Prior to talking about the guiding principles for effective 21st century road design process, I want to mention a little bit about the performance-based geometric design process. The typical purpose of the geometric design process is to provide the necessary three-dimensional features for a roadway to address stakeholders' identified problems or needs by providing an appropriate level of mobility and safety improvements for all road users. The traditional philosophical approach to design has been to treat minimum design criteria as adequate to produce acceptable performance. The goal has been to meet these standards or criteria rather than to specifically provide sustainable traffic operations and safety. Some of the dimensions or models have not changed over the decades. The typical updates of the Department of Transport or road agencies' policies and guidelines have been focused on various individual design elements and not on the overall design process. An assessment of the existing design process was undertaken by a range of practitioners to suggest changes to ensure that the recent advances in knowledge and emerging issues are incorporated in the design process. In the recent years, strong stakeholders' interest has emerged. A geometric design process that is responsive to these issues requires measurable transportation or environmental impact terms. This dialogue between design professionals and stakeholders is essential for developing an optimal solution balanced with the transportation and community goals. The transportation knowledge base has grown over the years. Research findings propose that the end goal of the geometric design need to be measured in the metrics of transportation performance, including mobility, accessibility, safety, maintenance, and operations and state of the good repairs. So what are the guiding principles for effective 21st century road design process? There are certain principles that should shape and define an effective process into the future. I characterize these guiding principles in three categories: the fundamental base for road design, the social and public policy framework within which the process is conducted, and the necessary attributes of the effective process. These principles are quite often changed depending on the jurisdiction, but the fundamentals remain. The following slides present what should be the fundamental basis for the design of the major urban roads. Number one, geometric design solution should address objectives and quantitative measures of transportation performance. Number two, social and political framework within which the process is conducted. Number three, necessary attributes of the effective process.